separating the signal and DC quantities. And here if you look at this circuit, this is a common emitter amplifier circuit. Why do we call common emitter? If you see the emitter part of this connected to the ground, and also that's one connected with the base as well, so that's a common emitter. And in this one we are going to analyze how we can separate. Currently if you see, we have a AC voltage and the DC voltage. Combination of both of them make the total voltage, and here this is a total current. So if you look at it, this is one also combination of AC current and DC current. Okay, currently both of them are combined in this circuit. So if you look at that, there will be a DC component in this one, DC component, and DC component is nothing but it's constant over time. And if you look at AC component will be changing with the time. AC components also called as signal components. It varies with the time. Varies with respect to time. For example, for the DC you can compare a straight line, and for the AC you can compare a sine wave. That will be changing with the time. Okay. And this one, if you look at this VBE voltage, this VBE is nothing but, if you see a small v capital BE, that's a total voltage. That's equal to DC component of the voltage, that's capital B capital V capital BE, and the AC component, that is small v small b small e, and this one is the total, and this one is the DC component of it, and this one is the AC component of it. Okay, DC and AC. And current also same. If I let's go to new page. So if you see a current, I capital C is equivalent to capital I capital C plus small I small c. So this is the total current, and this one is the DC component of it, and this is the AC component of it. Okay. And here we can separate DC component and AC component by removing one of them. Like if I'm interested in finding the DC components and the DC quantities, what I have to do is I have to remove this AC component, so all the other things will become DC component. So to illustrate that, I copy this one and put it over here. Let's put the node first. So DC component can be determined by making AC signal as 0. Okay, now I bring the picture here, make it a little bit smaller. Okay, so let's see what's gonna happen if I make this one a DC component. So the parts that will be changing is, okay, first we won't be having this VBE. This is a AC component, we remove this one, so only the DC component will remain. Okay, let's use the same color. And this total voltage is unnecessary because the only thing we are going to have is DC component, and this current will become DC current, that is capital I capital C. And also, if you are interested in the current through the base, that is IB, capital I capital B. Okay, and others almost the same. Okay, that's the difference. And considering DC components, we will get to know all DC signal and components. And for the AC components, similar to this, I can paste it in the next one, but let's mention it first. So AC components, can be determined by eliminating DC signals. Okay, I paste the same picture. Here what we'll be doing is we make the DC voltage to be short circuit, and we will be make the DC circuit source to be open circuit. Okay, let's bring the same diagram. Here what we do is we just remove the DC component of it. Then if we do that, this part will be gone, and this part is unnecessary because we only have a AC component, and this one become small I small c, and others remain the same. So small VB remains, and this one is small I small c, RC VCE. The current through this is right now small IB current, and this one is IE current, emitter current, and this one is IC, IB, IE. These are the three currents we will have, and other than that nothing else. So considering AC components, we will get to know all AC signals and components. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next